Hello, welcome to my Build a Lecture 2. This one's going to be focused on Chapter 12, which is the antimicrobial treatment. Antibiotics. Why do we need them? What makes them so important? Well, I'll tell you. They rid the body of infections. Without antibiotics, we would die from something as simple as the common cold, strep throat, anything similar to that, like just the most mild thing that you could imagine could possibly kill us. In fact, it wasn't, just only a few short years ago, by some means, more like 60, 70 years ago, even further back than that even. It wasn't unheard of for people to not survive, past infancy due to certain illnesses. A lot of children actually didn't even make it to the age of 5. The age for adulthood that was considered like old age back in like the 1700s, 1800s was actually around 25 to 35 years old, which is the average lifespan of life, just because people would get sick. It wasn't common to live very long. Living to almost 100 was almost unheard of. Antibiotics are very important. Their creation literally changed the world. In instances of surgery, they can prevent infection from occurring. So, like, major surgeries especially, like I consider, a C-section when a baby's born to be a major surgery. You're going through several layers of tissue, from skin, muscle, nerves, just everything's getting cut up. You're going through like 7 or 8 layers of, skin and stuff to get. Then you have to cut through the uterus, and then you cut through the amniotic sac to get to the actual baby. So when they're stitching you up, there's so many different layers in between, where bacteria can get in and set up an infection. It's just like this big, huge, gaping wound that's open for, it takes them about, I think, 30 or 40 minutes to sew you back up. So there's plenty of time for pathogens to get in. So they're more than likely going to probably put you on a regimen of antibiotics or whatever through probably an IV line to help you not develop an infection. Antibiotics save lives every single day. Like, we don't even realize it. Something as simple as getting something, like strep throat or something. We don't think anything of it when we get a sore throat now. We just go to the doctor. They prescribe us some medication, typically something like amoxicillin or Z-Paks, because they'll continually working in the body's system even after you've already taken them to clear up the infection. We think nothing of it. It's just everyday life for us. But, back in, like, before the 1900s and stuff, before, a lot of antibiotics were really around, just strep throat would kill you. Like, it would kill the average person. Like, it was not heard of really to survive something as simple as strep throat without antibiotics. They kill harmful bacteria. Another important aspect that was in this chapter was probiotics and prebiotics. These things work to prevent and cure infections as well. They're just as important as an antibiotic, really. They go hand in hand together, and they work together, kind of like a mutual friendship. Antibiotics can cause new issues that these two can help prevent. Prebiotics. Prebiotics are mixtures of living microorganisms that are consumed by people and animals to regulate and improve their gut biota. Prebiotics and probiotics help, balance good bacteria with bad bacteria. They create more good bacteria, which will in turn destroy the bad bacteria. They also help improve digestion in your gut microbiome. They boost the body's immune system and help fight off infections. They can prevent infections caused by antibiotics, specifically talking about, stuff like yeast infections you can get from taking drugs like augmentin and amoxicillin. They're very prevalent for causing yeast infections. Sometimes antibiotics can cause infections when you take them, so it's kind of like you can't win. You're trying to fight one illness and you get stuck with something else. But prebiotics and probiotics can help prevent this. So it's always good to take them when you take any kind of antibiotic, especially something like yogurt. Yogurt is an excellent probiotic. Next we have prebiotics. Prebiotics are foods that we consume. They're usually high in fiber, and these will feed the human microflora. Foods that are high in these are typically stuff like bananas and soybeans and whole grains. They're very high in these. And as I said before, yogurt. Yogurt is an excellent source. next part I'll be touching on is antibiotic resistance. This was actually one of my favorite parts of the chapter, as this is something I am familiar with. Antibiotic resistance simply means that a drug that once worked great now doesn't work so great. Bacteria can become used to antibiotic used instead of actually, killing it off like it should. It is not always caused by overuse, which is something I was always told growing up. It can be caused by not completing treatment cycles, however, which is something I was also told. So remember, if you get prescribed antibiotics and stuff for when you're sick, always complete the whole entire cycle that you're prescribed. This is very important. If you don't take the full cycle you prescribe and you just stop taking it because you feel better, that doesn't mean you're better. It just means that you basically silence the bacteria and stuff for now, but they're going to build up and get stronger and become what I would like to call a superbacterium. And eventually one day we can end up creating, diseases and stuff that we do not have antibiotics for, and it can be very disastrous. This is something that scientists are worried about for the future and stuff like that. They believe, however, that it's caused mostly by random gene mutations in important chromosomal genes. It can also be caused by new genes being exchanged between species at random. This is kind of like what happened with the very first antibiotic resistance that was shown. It was actually the drug penicillin. It was one of the first to show antibiotic resistance. And the funny thing about it was it hadn't even really it wasn't circulated through the public at the point that it actually showed signs of antibiotic resistance. So that really just proves that it was caused by a mutation that happened within the actual, medicine unto itself. It wasn't really exposed. But it's not extremely common, but it's still a worry for the future. So like I said, remember to take all of your medicines. On to the next slide. Ideal antimicrobial drugs. Well, an ideal antimicrobial drug would only be harmful to the agent causing the infection and the illness, and not to the person that the antibiotic is for, which would be the host. That's not obviously always the case. Sometimes antimicrobial drugs can cause harm to the host just as much as they cause to the bacteria, and sometimes even more so. An ideal antimicrobial drug would break down easily in the body fluids and then exit without causing, any uproar in the human body. They would also either extremely delay resistance response or cause no resistance response when it comes to pathogens. They would continue to be active in the body long enough to destroy the bacterium, and they would also cause no side effects in a dream world. One of the most common side effects that you'll see from antibiotics is diarrhea. You can also have stuff like vomiting, headache, fever, but diarrhea is the most common. The problem with diarrhea is it can become colitis, which can cause a whole slew of other, effects down the road, which eventually could end on something bad like, colon cancer. To begin, well, before any antimicrobials or antibiotics are started, you need to know 3 important things. First, you need to know what type of microorganism you're dealing with that's causing the infection. This is extremely important. Number 2 is pinpointing what drugs will destroy the pathogen effectively, and most importantly, what is going to destroy the pathogen but not adversely affect the host. You also need to know whether the patient has any medical conditions, especially things like diabetes or cancer, and it's important to know what they are. They do this by testing bodily fluids, such as urine, sputum that comes from the respiratory system, testing stool. It's a means of seeing what type of bacteria or virus has actually infected you before they can prescribe any antibiotics. This is the most effective way to make sure that the treatment works. It's not necessary for things like penicillin or A-type streptococci. Finally, we're going to cover the bad side of antimicrobials. Not everything can be sunshine and rainbows, and antimicrobials are no stranger to that either. Antimicrobials can be toxic. They can absolutely harm the host just as much as they help. They can cause adverse side effects. They can cause anything from kidney failure, liver failure, heart problems, colitis, as I said earlier, like I was talking about with penicillin drugs like amoxicillin and stuff like that. If you take those, especially if you're a woman and you take stuff like amoxicillin, it can cause a yeast infection, which is a secondary infection. They're not always effective. They can cause more problems than they help. and they can kill healthy bacteria that will keep the body protected. I hope you enjoyed this slideshow, and thank you so much.